Hello everybody, welcome to a new series where I teach you how to use the Kerbal assembly language for the Kerbal Operating System or kOS mod for Kerbal Space Program. In this series I'll be teaching you how to write in Kerbal assembly, but also a little bit about how Kerbal Operating System works so that you can get started writing your own programs. This is more targeted towards intermediate Kerbal Operating System users, although in theory anyone can follow along. In this video, I will be showing you how to install all of the necessary tools for Kerbal assembly, but also how to write a script that launches this rocket, although it won't do anything too crazy yet. The first step to get started is going to the link in the description, which is to the GitHub repository for Kerbal assembly language. And it has README that you can read through with instructions, but I will go over all of the instructions in this video. And there is also a documentation library which was written so that anyone can get started if you would rather read instead of watch a video. So in order to install Kerbal Assembler, you go here to the releases page, and in this case the Windows installer. I have already downloaded the Windows installer. You just double click it. I have not signed any of my executables yet, so it will come up with this. If you don't trust my executable here, then there are instructions for building the code from source. It's all open source, so you can read all of the code. But in this case, I'm just going to click run anyway, and it's a very simple installer. All the default settings are totally fine. And then I will click finish, and now we can test if we have it by opening up the terminal, either command prompt or PowerShell, but I prefer PowerShell. And then you just do KASM -- version. And you can see that we have KASM 2.0.3, which is the latest version. Then we also need Visual Studio Code or any editor of your choice. I prefer Visual Studio Code because I made an extension that allows you to have syntax highlighting for Kerbal assembly language, which helps a lot. It also has an extension for KerboScript, which is also helpful because you might be writing a lot of KerboScript, compiling it, looking at the Kerbal machine code files, in order to have a reference when you're actually writing Kerbal assembly code. So here I'm just installing Visual Studio Code, and we're going to navigate to the scripts folder under ships in your Kerbal Space Program install. In my case, it's under my kOS testing install, and it would be under ships script. You've seen this before if you program in Kerbal Operating System with KerboScript. So here we're in the scripts folder, and we are ready to get started. So you may also be wondering why Kerbal assembly language exists. I made it because there seems to be an interest in writing in other programming languages in Kerbal Operating System. Obviously there's KerboScript, and many people have already tried making their own languages and they compile to KerboScript, and that can work, but the KerboScript compiler isn't necessarily the most optimized, and if you write your programs in Kerbal assembly, then you can theoretically get your binary size down if you're in, let's say, starting science mode, or you're otherwise worried how much space your script is going to take up. The files can be smaller, and theoretically you can use less Kerbal machine code instructions, which would allow your programs to maybe be faster as well. If you're looking for optimization, this may be the route because you can mix Kerbal assembly and KerboScript. This also allows you to develop new programming languages for Kerbal Operating System easier as well. Instead of transpiling to KerboScript, you can actually compile to Kerbal assembly, and that allows you to have a lot more fine control over what your programming language actually does. There are a lot of things that you can't directly do from KerboScript, and that is a design from the people that wrote kOS. But in theory, you can more easily develop certain programming languages. So it's to support faster programs and new programming languages. Here we're just going to start out by actually making a KerboScript file. This is the code that we're going to be imitating with our Kerbal assembly. Before we start, we're actually going to want the plugins for both KerboScript and Kerbal Assembly. We can just search KerboScript under extensions, and this seems to be the best one, more recent. So we're going to install this one, and then Kerbal Assembly, and we can install that. So now we have both. We can see Kerbal Operating System as the type here, and we're just going to do something very simple. We are going to launch the rocket straight up, full throttle, and stage. How you would do that in regular KerboScript, you would lock the throttle to 1, lock steering to up, stage, and then you might do something like wait until false. We can run this program, and if you're familiar with kOS, it's going to launch our rocket straight up. Now that's pretty interesting, but we're trying to write Kerbal assembly here. So we're actually going to switch to 0, and then here's our launch.ks file. So I want to show you how you can actually examine KerboScript files that have been compiled. There is a tool that you installed with KASM, which allows you to do that. So we're going to compile launch.ks, and then we can go back to VS Code here, and the tool that you use to look at Kerbal machine code files, the KSM file here that's been generated, is the kdump utility, and we're going to do full contents and launch.ksm. So this is a pretty big script, so there are actually a lot of things that happen behind the scenes in throttle locking and things like that. But this is basically, you can see the actual machine code instructions that we're going to be actually writing in Kerbal assembly. Not this many, but these type of things. So you can actually examine any code from KerboScript using this method. So instead, we are going to create a new file, launch.kasm. And we're actually going to delete both of these files. So you can see that this is also recognized as Kerbal assembly. In order to start writing any KASM program, we're going to define what's called the entry point. So if you're familiar with other programming languages or assembly language, this will make a lot of sense. kOS needs to know when our code starts, and this is how we do it. It looks for something called _start, and it's a function, and we can start writing our code here. So the first instruction I'm going to put down is the end of program instruction, which tells kOS that our program is over. I'm always going to put that at the end, and it's good practice to do so in your programs as well. Before we do anything, let's do a little hello world. How you do hello world in Kerbal assembly is that you call the print function, just like in KerboScript. And now you can see actually how that happens. You're going to push, and then hello world, and then call print, and then pop. What's actually happening here? Kerbal Operating System is what's called a stack-based computing platform. There is a stack, and if you're not familiar with stack data structures, it's basically a place where you can put variables and they live sort of on top of each other. Here we push what's called an argument marker, which tells any function that you call where the end of the arguments are. So if you call print, we would do it in KerboScript, you would just say print hello world, and it would actually do the same thing. It looks at the first argument and then tries to print it out. This tells it that we're done giving it arguments, and then we push the string hello world onto the stack, and then we call print. All built in, and all functions for that matter, in Kerbal Operating System return something. Even if you don't say, return a number, return a string, return a maneuver node, even if you don't say so, they all return something. So in this case, they just return 0 or null, and we just pop that off the stack so that the stack is clean. We'll go and do a little bit more demonstration on how the stack works later. But for now, this should print hello world. So how you compile a KASM program is you write KASM and then the name of the file. And that will actually generate a KO file. This is a Kerbal object file. It's a format that I had to make that allows you to combine multiple programs into one. But we'll get to that at a later date. For now, all you need to know is that you actually have to run a separate command where you give it the KO file and then you say launch.ksm. You run that and it ran without any errors, so all of our code is correct syntactically. Then we can go back to Kerbal Space Program, we can list, we see all of our files, and we can run launch.ksm. And as you can see, it prints hello world. Going into it a little bit deeper, instead of hello world, let's print a number. But in order to demonstrate a little bit more about how the stack works, I'm going to add two numbers together and then print the result. This will be equivalent to, and you use a semicolon for comments in Kerbal Assembly, equivalent to print 2 plus 2. We are going to push 2 because all instructions actually use the stack. Some take no arguments off the stack, but any ones that do will use the stack. So we'll push 2 again and then add. So why did we do that after this? It's because this stack actually sort of works in reverse, because when you pop something off the stack, it comes off of the top. When you push something, you push onto the top. We want this to be the last thing that print sees, because the first thing is supposed to be what we want to print out. So we push that so it's on the bottom, then we push 2, and then we push another 2, and then we add them together. So this pops 2 things off the stack and pushes the result back onto the stack. After this add instruction, our stack is going to be the argument marker on the bottom, and then the result, which should be 4, and then we're going to call print. It's going to take 4 off of the stack, and it's also going to take the argument marker off of the stack and say, yes, there was only one argument. Because if there are more things on the stack and it doesn't see the argument marker as the second thing, it will throw an error and say, hey, you gave me too many arguments. Then we call print, and then we pop its result off the stack. So we can run these commands again to recompile our program, and we can go to kOS and run, and it prints 4, just like we wanted. So now to do something a little bit more interesting and actually command our rocket. So if you're familiar with the launch script that we had written before, this will not look too different, although just the way that you do things is a little different. We are going to need to set the throttle, set the steering, and then stage so that our engine is activated. Setting the throttle, if you remember from KerboScript, you use the lock keyword. You would lock throttle to 1. If you actually try to set throttle to 1, kOS will throw an error. But it turns out in Kerbal Assembly, you can actually just set the throttle. There are a bunch of reasons why you don't want to do this, but for our very simple script today, it will work. There are many reasons why you want locks, and that will be in a future video. We're going to push 1, which is what we want our throttle to be, and we're going to store globally. So store into a global variable what's on the stack. And we're going to store it in a variable named throttle. And in kOS, internally, and therefore in Kerbal Assembly, all variable names start with this $sign. So this will store 1 into our throttle, which is exactly what we want. Then we'll want to actually set our steering to up. So up is actually internally a variable which just stores the current up direction. We just push the value stored in up onto the stack. And then we store that into steering. Now this would sort of work, although there is one more thing that we need to do. When you actually command throttle or steering to something in Kerbal Operating System, the compiler automatically inserts something that we need to do manually. I'm actually going to define this as a macro, and it's going to be toggle fly by wire. So many of you may have called this function yourselves, but when you lock the throttle to something, it automatically calls it. So we call it like any other function. We're going to push &1, and I'll explain this after I'm done writing it. Push true, call toggle fly by wire, and then pop. Here what I have defined is a macro, and basically when we write this in our code, so toggle fly by wire, throttle, and then toggle fly by wire, steering, this actually basically does a copy and paste. So I could have written this 2 times in here and changed out this for throttle and steering, but instead I wrote a macro. It's not a function, it's a macro, so it copy and pastes. But this needs to be called so that kOS knows that you want to drive the steering with your script. This is actually a function that takes 2 arguments. The first argument seems to be that you actually want to enable fly-by-wire. And then the second argument is going to be what control you actually want to set. So in this case, it's throttle and then steering. And then here's the argument marker. So this is the first argument, second argument, and then the marker that's the end of the list. And then this, as with all other functions, returns 0. So we pop it off. So we have set throttle to 1, set steering to up. We do our housekeeping toggle fly-by-wire. Now we actually need to stage. So how do you do that? Well, stage is actually just a function. We can push @. We can then call stage and then pop. This will call the stage function. So just as with KerboScript, we actually need our program not to stop. We use the wait until false. Here we're going to do something a little different, and we're just going to make an infinite loop. We are going to put a loop label. This is a place in the code that we can actually jump back to. And this is a local label, so this is really _start.loop. This allows you to find the same thing in multiple functions. We're going to push 0. And then we're going to call the wait instruction. So you can do wait 0 in a lot of places in your KerboScript code. This is exactly what it is. This is wait 0. And then we're just going to jump to the top of the loop. We're going to wait for 0, and then we're going to jump to the top, which is going to be here. This is just going to execute forever. We're going to compile this and then link it. And then we can go back to KSP and run launch.ksm. So this does exactly what we wanted it to. It locked the throttle to 1, it set the steering to up, and it staged. So this is excellent. We've written our first Kerbal assembly programs. This is just going to go into space and come straight back down. So it's not very interesting, but I hope to see you in the future videos